Okay, scenario where you're provided with 2 points, you have to find the third point. Okay, provided 2 points, find a third point using symmetry. That is where, I kind of alluded to that, and you've already done that, but not regarding a word problem. And it's actually easier to do with a word problem than it was before, where you had to use the equation for the axis of symmetry to find that other point. Best way to solve is to sketch first. Okay, sketch it first. Remember that the third point is across the starting point. The third point is across the starting point. I will emphasize that because, and I will show you the common errors that I see when this comes up. So let's go through some scenarios. We're not going to do regressions. I just want you to come up with the 3 points. Okay. So let's say it's a bit small. I apologize, but it says here the starting point and the vertex is given. So let's say a ball is kicked and reaches a maximum height of 17 feet after 1.25 seconds. So if a ball is kicked, they don't have to tell you that. What are you starting at? The first point is 0, 0, right? The ball is kicked from like right on the ground. Then it reaches a maximum height after 1.25 seconds. A common error is students mix this up. But if time is here, time is always at the x-axis, right? So it's 1.25, watch this, 17. Okay. So after 1.25 seconds, you reach that maximum height of 17. And so what would this point be using symmetry? The line is a little thick, but if you go across, right, this is your starting point, right? That's your start right at the corner. Let me zoom into that. You start, the vertex is given, move all the way across to get the time. This is my third point. And we use the symmetry of this parabola. If it takes you 1.25 seconds to make it to the midpoint, how many seconds is it going to get you to get to the same height again? 1.25, right? So to get the time it would take you to reach the same height that you started off with would be basically just multiplying this by 2, right? And so you get 2.5, 0, right? Why 0? Because 0 was the starting point. So you go x and y, right? Time and height. You fill that in. 0, 0. At the very top, you're at 1.25, 17. And this is the one you found, 2.5, 0. And I will make a note here. I will highlight, I should say. Notice that the starting height was the same as your end height. Okay? Starting height is the same as your end height. Start, end. Okay? Let's go through another story. Okay, so let's say here, off the ground. So this one was on the ground. Now we're going to do a scenario off the ground. An object is thrown from a height of 8 meters, reaches a maximum height of 13 meters at a distance of 3.5. So notice that we have distance and height here. This is the sketch I would want you to do. I just provided this for this demonstration. So at the very beginning, we are at 0, 8. Okay. At a distance of 0, that's when you're going to throw that object, you're at a height of 8. Then it tells you that at a distance of 3.5 meters, you reach the maximum height of 13 meters. Okay. And this is where the kicker comes in, guys. A lot of students go straight down to the x-intercept here and just like, this is my third point because you just told me that it's there. But remember what I told you to highlight? The third point will be across the starting point. So you basically go across like that, same height, and you put the point right there. And you use symmetry again. Okay? If it takes you 3.5 meters to reach the highest point, it will take you another 3.5 to reach that same height again. Okay? So this point is really just taking that, timesing it by 2. So you get 7. And this number is going to be 8, right? 7, 8. Those are the 3 points there. Don't go to your x-intercept. Listen, I will ask you for that x-intercept, most likely. And if you just say, oh, it's 7, 8, because a lot of students put the 7, 8 down here. I wouldn't give you a mark for it, right? You already found it, right? So that should be an indication. It's like, oh, I made a mistake. I got to go back and put it elsewhere, right? So this is going to be our chart, x, y. Let's put distance and height as well, right? Distance and height. And just fill that in. 0, 8, 0, 8, and then 3.5, 13. And then it's 7, 8. Let me highlight the important. If points are given, it's not necessarily going to be the case. But in this case, you're finding the third point, right? So start, end. I should be careful here. This is not the end of the story. It's just from where you start till that third point, right? That's what I mean by that. So I'm a little bit, I don't know if I should do that, but I hope you understand what's happening there. So let's see here. How about the other way around? Let's go to the second half here. Let's zoom into this one. Start and end point given, no vertex provided. Like, what if no vertex is provided? Like, they don't tell you, hey, it reaches the highest point. Like, it doesn't tell you that. Or it doesn't give you the complete picture. So let's look at this scenario. As an object is thrown upwards, reaches a maximum height. So there's the maximum height of 40, and then lands and remains airborne for 8 seconds. There was a bit of a typo there, but anyways. So object is thrown upwards, reaches a maximum height of 40, and lands 8 seconds later. So you should recognize that this is 0, 0 here. If it's thrown up, you're starting on the ground, and it's times 0. And then this is also given. This is 8, 0. It takes 8 seconds to hit the ground, which means the third point is this one right here. Which one do you know already? You know the 40, right? That should be here. So you're partially there. So how would you find that point? We used to go times 2 to get here. Now you're going to have to go divided by 2. So that'll be 440. Okay. And the idea is the same thing. Let's use the axis of symmetry. This is 4 and this is 4, right? But you're basically splitting the 8 into half, right? So it takes you 4 from the start to the middle to get you that. So in this case, you just have to divide by 2. I'm just going to go x, y. So it's 0, 0, 440 and 80. It's probably worth highlighting again that you're on the right track when you see something like that. Same height. Same height. Or same y value, right? Okay. And let's do one that is a little bit different, because most parabolas point down, but from time to time you will have one that points up. So here we go. A skier goes down a 30-foot ramp, right? Lowest height is 12 feet and reaches initial height at a distance of 50 feet. You're like, wait a minute. So a 30-foot ramp, if this is the ramp, then it's 0, 30 here. Okay. The lowest it reaches, right? The lowest height is 12 feet. And I'm going to use red here, but this one, right, is 12 at the lowest point. And we have to be careful here. They're telling us this is the most challenging of all. What would this be here? My x value would be a distance of 50 feet, so that'd be 50. And what's the y value? It's going to be 30, right? Because you're where you started, right? That's the point across. So to get the x value, right, that would cut this in half, you just need to divide this by 2. My apologies, I didn't leave you a whole lot of room there. So that'll be 25. So for your x and y, you have 0, 30, 25, 12, and 50, 30. Emphasis on the 30s. Okay. That would have been time. Oh, you mean the entries there? Okay. So now let's do an example. And then the rest of the class will be for you to work on type 3 or type 2, whichever one you prefer. Okay? So this is on page 29. Calculators ready? Don't hurt yourselves with those staples. Roger would like to recycle his beverage container. He throws his container up from a height of 1.75 meters and estimates that it reaches a maximum height of 2.8 meters after 0.75 seconds. The container lands on the rim of the recycling bin, so it doesn't get it in. Right? Roger, come on. The bin is 0.65 meters tall. So I picked a challenging question here. Okay, so let's highlight the important things. Throws it from a height of 1.75 meters. That's definitely worth highlighting. Okay. What would that be? Our initial height, right? That's the initial height. That's the initial height. It reaches a maximum height, right? Maximum height of 2.8 meters after 0.75 seconds. That's your vertex right there. You should recognize that. The container lands, right? It lands on the rim of the recycling, and the bin is this tall. So let's see what this looks like. Determine the quadratic equation that models the path of the container. So this is where you need to do one of these. Okay, just sketch it. I will not mark this based on scale or anything like that. Just sketch it. This should be time, and this should be the height. Distance and height go in the x-axis. Height obviously goes on the y-axis. And then just imagine this, right? Roger is throwing this like this, and then hits the rim, right? This is like your garbage here, right? I'm going to zoom into that. Anyways, so we know that this is at time 0, this container is at that height, 1.75. It reaches a maximum height of 2.8 meters. So this would be 0.75, right? The time comes first, then the height. And this is here to throw, sorry, go ahead. And this is to throw you off. I did this on purpose. What's this one right here? What's the height? 0.65. Do we know how long it took to get there? We don't have a clue. Right? Go to your starting point. When you have a question like this, go to your starting point and go right across, right? This is here. I want you actually to have an arrowhead there. This is the point that we can find out. We can't answer this just yet. Does that make sense? You're not at the same starting height, and I threw that in there to kind of trick you. So I sort of apologize for that, but not really. Okay. So we can find this one though, because we know that the height is 1.75. At some point, it comes back to that height, and it would take me twice as long as it took to get to the middle. So we're going to go times 2, and that's 1.5, right? This is the third point. That is your third point. I will now I will make my table, X and Y. I strongly recommend you do that. You go 0, 1.75, then you go to your vertex, and then you go back to where you started. Okay. Put a question mark here on this one. I can't do this one yet, right? Can't do that one. I should have threw it in there. There's a chance that you will need it later on, right? For domain and range or anything like that. So watch out for that. Now we go L1, L2, stat, calc, 5. Should have left you way more room there. But let's go ahead and do that. So go to your L1 and L2. So it's 0, 0.75, 1.5, 1.75, 2.8, 1.75. I will double check if you did this right, okay? Takes a few seconds, and then you go and perform the regression. And this is what I get. Y is equal to negative 1.87. x squared plus 2.8x plus 1.75. That should not be a surprise to us. You can't see that, sorry. That should not be a surprise to 1.75 at the end. All right. Now, how long, right? They're asking for time. Does it take for the beverage container to reach the rim? Right? Time to reach the rim. That happens, right? That happens at a height of 0.65 meters. So we know the y value, so we let y2 equal to 0.65, and then we're going to go second trace 5. This thing never hits the ground, right? Roger doesn't go and pick it up, I guess, and it doesn't do the right thing. And so how do we do this? Well, we graph it, and let's go zoom 9. And this one is actually always one of the easiest ones because usually word problems like these are not, you don't have huge numbers necessarily. So I'm going to go change my x min, x max, I'm going to change it to 3 maybe. Y min, I'm going to change it to negative. I'm not talking big numbers here, so I'm just going to leave it like that. My max is 2.8, it tells me, so if I keep that at 3, it should be fine. And there it is. There's my, and we're only concerned with quadrant 1. Y2, I will make that 0.65 and graph it. There it is. I don't care about this negative here. I only care about that one. So second trace 5. Enter, enter, enter. And that would give me, and that would be seconds. Okay. It takes 1.82 seconds. Technically, everything that comes now, you should be able to do, okay? But I made this challenging for a reason because I wanted you to really have to think, okay? How long does a container remain below 2.5 meters? Okay, below 2.5 meters. So we will make y2 equal to 2.5, and we're going to go second trace 5. There's something I need with y. Y needs to be 2.5, and then let's explore this a little bit. This is interested, if you look up on the screen, it's interested in the times it was here and here. It wants the times below, right? So listen carefully. I'm going to focus on finding the time it spends here and subtract that from the total travel time. Does that make sense? I will find out how much time it spent above and just take that away from the total time it took to hit the rim. That's how I would suggest you do it every time. So we do it just like before. Second trace 5. Find the first one. I'm going to go a bit to the left. I can see my cursor there. I don't know if you see it. It's right there. I'm going to find that first one. Time 1 is 0.3491. Time 2. This is going right back to word problems before, right? Once you have an equation, anything goes. 1.1509. Okay, so I'm rounding them both to 4 decimals. And watch carefully with your notes here. Time at or above 2.5 meters. I'm going to cut this here like that. Time at or above 2.5 meters would be just like before. 1.1509 minus 0.3491. Let me zoom into that. And so I will go ahead and subtract those. And that is 0.8018. I'm not rounding yet. So this is if the question had asked you, like if you subtract those 2 times, like you find above, right? Time below 2.5 meters. Let me just scoot over. Would be this. Total minus delta time. So it would be 1.82 minus 0.8018. It's somewhat of a rare question, so if you're a bit scared, don't let it scare you. Okay? It's not that bad. So I'm going to go 1.82 minus 0.8018. And so that's 1.02 seconds. So recap, I found how much time it spent above that. So if I know that it takes 1.82 seconds in total to travel, I'm going to take that away. So now I know how much time was spent below 2.5 meters. That's graph, do the domain and range. Go ahead, Marcus. And do the domain and range, and then we'll go ahead. Okay. So time in seconds, height, and not seconds, meters. Meters, yeah, meters. Time in seconds, height in meters. I have everything I need, really. 1.82, right? So let's see. 0.51, 1.52. That's a pretty good. Right? So 0.5, 1, 1.52. It's a pretty good scale. And the highest altitude is 2.8. So if I make this 1, 2, 3, yeah, that works pretty good. So I'm at a height 1.75. This is 1.5, 1.75 is right there. Then at 0.75, I'm at a height of 2.8. Should be right there. And after 1.5 seconds, I'm back to where I started. And you're like, yeah, okay, but what else is missing? I need the garbage bin, right? It's in a land on the garbage bin, which is 1.82, 0.65. So this would be 7.5 right there. 6.5 is right about there. So it should stop there, right? Wow, look at that parabola. That's a pretty good parabola if you ask me. 1.87x squared plus 2.8x plus 1.75. So in this case, the scenario, it stops, right? There's a start and a stop. Start is it's always there for word problems. It's the end. It may hit the ground, it may not. So just watch out for the wording. State the domain and range. Let's go ahead and do this. My domain goes from 0 until it hits the rim. So time is delimited between 0 and 1.82. My range is between no zeros, right? Yeah. 0.65 and 2.8. That's the highest point and that's the lowest, right? Lowest first, highest second always. And then all right, guys. And now you know why I pushed the quiz to Monday. Because I know it's a little bit too much right now to quiz you tomorrow already. So we have over 20 minutes, okay? And remember, if you start it here, you're more likely to end it at home. So I would say I want to focus on type 3. So I would say do this these questions down here, page 22 to 25 in the workbook. Start with type 3 and then go to type 2 at a later time.